Hello dear space lovers, welcome to the Explorers. Today we're gonna see part 2 of satellite NISAR. The link of part 1 is given in comment section and in description. I hope you would like our content. So let's start the video. So first let's see phases of the mission. The launch phase. The NISAR observatory will be launched from Satish Dhawan Space Center, Sriharikota on the southeast coast of Indian Peninsula on GSLV expandable launch vehicle contributed by ISRO. The target will be launched on 30th March 2024. The next phase is commissioning phase. The first 90 days after launch will be dedicated to commissioning or in-orbit checkout, the objective of which is to prepare the observatory for science operations. Commissioning is divided into sub-phases of initial checkout, spacecraft checkout, and instrument checkout. The last phase is science operations phase. The science operation phase begins at the end of commissioning and extends for 3 years and contains all data collection required to achieve the L1 science objectives. During this phase, the science orbit will be maintained via regular maneuvers scheduled to avoid or minimize conflicts with science observations. So these were the phases of this mission. I hope you would understand them. Now let's see about the objectives of this mission. The NISAR satellite represents a collaborative effort between the NASA and ISRO, launched with a goal of advancing our understanding of Earth's dynamic processes. NISAR serves several key objectives. One primary objective is the precise monitoring of Earth's surface deformation. NISAR employs advanced synthetic aperture radar technology to capture high-resolution images, enabling scientists to detect fine changes in the Earth crust. This capability is valuable for studying tectonic plates movements, seismic activity, and other geological phenomena, contributing to a deeper understanding of Earth's geodynamics. Another crucial role of NISAR is the observation of ice sheet dynamics. The satellite radar system allows the detailed mapping of ice sheets in polar region, facilitating the monitoring of ice thickness, flow rates, and changes over time. This information is vital for assessing the impact of climate change on polar ice and understanding its implications for the global sea level rise. NISAR also focuses on measuring biomass and soil moisture. By utilizing its radar capabilities, the satellite can provide accurate and frequent measurements of vegetation structure and soil moisture content. This data is instrumental for monitoring ecosystem health, studying carbon cycling, and improving our ability to manage natural resources. In addition to its scientific objectives, NISAR also plays a crucial role in disaster management. The satellite provides essential information for hazard assessment and disaster response planning. Its ability to capture detailed images of Earth's surface allows for the identification of potential risk, monitoring of changes that may precede disasters, and aiding in post-event damage assessments. Now let's see the detailed information about NISAR. Before going to the video, you should know about the terms like polarimetry and interferometry. You might be thinking why? Because the NISAR is capable of working in full polarimetric and interferometric modes. Interferometry is an imaging technique in which waves are superimposed in a manner to cause interference. NISAR will use interferometry to compare three-dimensional observations of the same scene on Earth to reveal surface motion and change. Interferometric synthetic aperture radar techniques combine two or more SAR images over same region to reveal surface topography or surface motion. If the combined SAR images originate from slightly different positions, the topography or distribution of the surface can be mapped. In contrast, if images from the same position but taken at different times are combined, the difference between them will show motion or deformation of the surface in time between the two images. The image produced is now known as an interferogram. It looks like a rainbow-colored oil slick on the surface of water. This fringe of colored pixels shows the difference in signal phase received by the radar instrument over time, which shows what has changed in the image. I hope you guys well understood about the interferometry. So now let's talk about the polarimetry. Polarization refers to the direction of an electromagnetic wave vector's tip. The direction of polarization is defined by the orientation of the wave's electric field, which is always perpendicular to its magnetic field. A radar antenna can be designed to send and receive electromagnetic waves with a well-defined polarization. By varying the polarization of the transmitted signal and receiving several different polarized images from the series of pulses, SAR systems can gather detailed information on the polarimetric properties of the observed surface, which reveal the structure, orientation, and environmental condition of the surface elements. For example, linearly oriented structures such as buildings or ripples in sand tend to reflect and preserve the coherence, same linear direction of the polarimetric signal. Randomly oriented structures such as tree leaves scatter and depolarize the signal as it bounces multiple times. Multiple polarizations and wavelength combinations provide different and complementary surface information. Okay, let's now come back to our topic, the detailed information about NISAR. Polarimetry and interferometry are the complex topics. I do agree. I tried my level best to explain them. If you still have any doubts, you can comment. I will reply my explanations. This flagship partnership would have major contributions from both the agencies. NASA is responsible for providing the L-band SAR payload system, in which ISRO supplied S-band SAR payload system. Both of these SAR systems will make use of a large size, about 12-meter diameter, common unfurlable reflector antenna. This would be the first dual-frequency radar imaging mission in which L-band and S-band using an advanced sweep SAR technique to provide L and S-band spaceborne SAR data with high repeat cycle, high resolution, and larger swath with capability of full polarimetric and interferometric modes of operation. It will provide a means of extracting and clarifying spatially and temporally complex phenomena, ranging from ecosystem disturbances to ice sheet collapse and natural hazards including earthquakes, tsunamis, volcanoes, and landslide. The precision interferometric orbit of the mission will enable in mapping few millimeters of deformities in the land surface. The selection of lower frequency band will cater to the need for better characterization of vegetation, which is vital for global carbon stock estimation and monitoring of carbon fluxes from vegetation. Similarly, the selection of L and S band frequencies will enable characterizing targets beneath tree canopy and subsurface features due to frequency penetration of signals in two-frequency. NISAR studying concepts for a synthetic aperture radar mission is to determine earth changes in three disciplines. They are ecosystems, which include vegetation and carbon cycle, deformation, which include solid earth studies, and cryospheric sciences, primarily related to climatic drivers and effects on sea level. NISAR will capture data over Indian coasts and monitor annual changes in bathymetry along the deltaic regions. The shoreline and erosion accretion also will be monitored. The NISAR mission will observe sea ice characteristics over the seas surrounding Indian Antarctic polar station, can be also used to detect marine oil spill and decimate the spill location during accidental oil seepage for preventive measures. I hope you would understand about the NISAR. So it's the end of our topic. I will be back with another video soon. Thanks for watching. Bye bye.